Hello and welcome friends. In this particular module, I wish to discuss about components of municipal solid waste processing. We will discuss about definition and scope of activities, components of municipal solid waste processing, waste management hierarchy, source reduction and reuse, recover and recycle, and current recycling practices in India. As you learn the content, you will be able to explain scope of the activities under municipal solid waste processing, explain elements of municipal solid waste management hierarchy, and also to state current recycling practices in India. Since our last presentations, we have been discussing about the functional elements of solid waste management. In the last presentation, we discussed about the transfer and transport of municipal solid waste. In this particular presentation, I wish to focus on separation, processing, and transformation. In order to have the better understanding of this particular element, we'll try to have various activities split up in this particular form. The way you see here, we were discussing about this transfer station facility, in which we also discussed that this particular facility can be equipped with material recovery facility, which would be having some application of intermediate as well as centralized sorting. So as the material is sorted out, the portion of it can be recycled. The biodegradable content of it can be further led for biological processing, where it would be transformed into the usable products. Through this particular biological processing, further, the remnants can be sent to this waste transformation, from where the material can be disposed, or through this particular material transformation, it can be sent to the thermal processing, and accordingly the energy can be recovered out of it. Also, it is possible that after this particular sorting, we can have this energy rich material separated, which can further be processed thermally in order to have the energy recovered, or the remnants of it can be sent through this particular waste transformation for the ultimate disposal. So, as you see, under this particular waste processing, we can deal with so many components in order to say the waste is processed. As such, the basic objective of this solid waste processing is to transform the segregated waste component or components individually or collectively so as to derive the useful product, certain material recovery, or the efficacy of next element. The way I was trying to mention, we wish to have this particular waste transformed so that it would be easier for us to have that disposed, to have that thermally processed, have that biologically processed. That means we are trying to increase the efficiency of the subsequent activity that we wish to take after this particular processing. As we move ahead, you'll be able to have the better idea related with each of these particular components related with solid waste processing. So according to our earlier discussion, the processing is an activity by which the solid wastes are transformed into new, more acceptable form or recycled product or products. So after this particular transfer station, we are having the waste stream divided into biodegradable waste, non-biodegradable waste through material recovery facility. So as we follow this particular biodegradable waste channel, subsequently it would be sorted out, it would be compacted, and further it could be composted, vermicomposted, or anaerobically digested in order to generate this particular biogas. As such, it is being transformed into the usable product. Whereas, as we think of this non-biodegradable waste, these are processed through the material recovery facility, they are compacted, and further they would be sent to the recyclable market, or they would be transformed into the refuse derived fuel, which can further be used as fuel in the waste to energy plants, and ultimately we would prepare that particular residue for its ultimate disposal. Here, as we process the waste either through the biological channel or certain thermal channel, we see that ultimately the residue remaining won't exceed 15% of the waste delivered to that particular processing facility. And further, we wish to have that reduced to less than 5% within the stipulated time frame. Here, this is certain guideline that we wish to follow as far as this particular processing is concerned. Through these particular processing techniques, we are recovering the material as paper, plastic, glass, ferrous, and non-ferrous metals. Also, we are recycling the material in order to have the usable products in the form of, say, biological products such as compost, methane, ethanol, and organic acids. Also, we can derive the thermal conversion products as heat, gases, oils, liquid and solid fuel, and also organic acids. In addition to this particular recovery of the materials, recycling of the materials, through the processing techniques, we can recover the energy, and also we attempt to detoxify the hazardous waste so that we can go for bioremediation techniques, phytoremediation techniques, incineration, and similar processings. Ultimately, after this particular processing, we wish to see that all the remnants would be sent to the disposal where the quantity would be considerably reduced as well as the quality of that solid waste would be changed to such a level so that it won't affect the atmosphere as a whole. In order to have the common sense out of these waste management practices for the layman, for the common man, through such ecology infographics, the attempts are made in order to make the people aware. As you see here, this particular graphics is telling about composting, incineration, zero waste, energy recovery, recycling, as well as landfilling in order to enhance the waste management practices. Also, the slogans such as reduce, reuse, recycle is also made popular. However, as we wish to attach the technical sense to all these particular management practices, we must follow the proper hierarchy among these reduce, reuse, recover, recycle, and similar terms. So, as far as this waste management hierarchy is concerned, the first and foremost step that we wish to have is reduction. This can be achieved by reducing the raw material requirement, by increasing the longevity of the product, by devising the better substitute and eliminating the need of the product. As we reduce this raw material and as we follow the practices associated with the reduction of the waste, the next strategy that we can think of is reusing. So here, after this reduction, still the waste arising out of the waste stream, we have to find the meaningful use of that waste before disposing it as waste. The third strategy is of recovery. Here, we wish to have the material objects recovered from the mixed waste stream. Here, we can think of the material recovery as well as we can also think of the energy recovery from the material. After having done with the reduction, reuse, recovery, then we can think of the recycling, wherein the remnant materials are to be separated from that waste stream. It is to be processed so that that material could be used as raw material in order to generate new materials. As such, here we lead to the concept of remanufacturing, the way the term is recently coined as far as waste management practices are concerned. Whatever may be the terms that we could be using, let it 3 R's, say let there be 4 hours, or there could be 5 hours, including these particular manufacturing. Even in some literature, we can see certain 7-hour agenda now, as far as this waste management hierarchy is concerned. But we have to concentrate on this step 1, step 2, step 3 through this step 4 in order to manage the waste effectively. We can have further understanding associated with these terms in the light of solid waste management. So, this source reduction and reuse are most preferred options as far as integrated solid waste management hierarchy is concerned. Because these are the options which are directly associated with the cost, associated with the handling, treating, disposing, as well as the impact of that particular waste on environment is concerned. This results in savings which accrue through avoided collection, treatment, as well as disposal costs. Further, that reduces the burden on the public authorities that are responsible for managing that waste. The reduction as well as the reuse and hence reduction in the generation of the solid waste helps to reduce the emission of these greenhouse gases which are associated with the climate changes. However, this particular source reduction or the reuse cannot be blindly accepted. There is a necessity to make the people well aware of the principles of reduction as well as reuse. Also, these particular waste management strategies require the policy interventions. Hence, developing this waste minimization program is very strategic step. For example, we can study the waste being generated at a place. We can have that particular waste quantified for that particular source. By studying the quantity, quality, and the waste generation practices, we can define the waste minimization strategy and we can define certain targets. In order to achieve these particular targets, we can identify certain waste management program. Accordingly, we can develop the policy as well as framework. Subsequently, the promotion of this active public participation or awareness of generation program would assist the execution of the policy developed within that particular framework. Subsequently, there is a need of integration of this waste minimization target in overall city waste management strategy. So, as we have defined certain strategy, as we have developed certain policy and the network, as we have involved the concerned stakeholders, as we have integrating the targets related with this waste minimization strategy, we can have periodic or annual monitoring of achieving that particular targets. So this will assist us how the strategy is being implemented. As we make out the lacunae of that particular system, we can further enter into the system and we can have and keep on revising that particular strategy till the desired targets are achieved for that waste minimization program. If we simply focus on reuse, it happens when something that already fulfilled its original function is used for another purpose. Through these particular pictures, we can get the fair idea associated with the reusing. So, typical reuse of glass or polyethylene terephthalate, abbreviated as PET water bottles, or old tires or certain street drums barrels as compost bins. Or a simple example of using these particular plastic bags as liners for the household waste bins can make the concept of this particular reusing very clear. Some lateral thinking can have these particular waste products used as aesthetical elements. Here you can see these particular old tires are used in order to have the road divisor. As well, certain green patches are developed through that particular old tires. Here, certain glass bottles are used in order to store certain kitchen products. Certain bottle is transformed into the vase as aesthetical element. Old barrels are transformed into the perambulator or toys. So, such things can be easily done through the concept of reusing. Through this term, we expect that the material that we wish to reuse does not involve the reprocessing or any further transformation except small cleanings and disinfection. Hence, this reusing concept can easily be adopted and implemented. However, there is a need to have certain precautions taken. And for that, there is a necessity of the people education. Say, for example, there could be certain material which are not expected to be reused as well as recycled. Hence, there is a need to have certain programs organized in order to educate the people for what they cannot reuse and what they are not expected to recycle. So, while devising this particular waste minimizing program, and as we are trying to involve the various stakeholders, making the people educated is also necessary, and hence this program also should encompass the reuse principle. As far as recovery and recycling is concerned, we can have that understood as process of transforming segregated solid waste into new product or a raw material for producing new product. This definition is given by Solid Waste Management Rules 2016 in India. Such kind of the recovery and recycling policy should be adopted before planning for processing or devising any treatment facility. Here, one can focus on processing non-biodegradable waste to recover commercially valuable materials like plastic, paper, metal, glass, and also certain e-waste. Such kind of the recovery and recycling diverts the waste from municipal solid waste stream, and also it assists the sustainable use of various resources. It also results in saving of scarce resources, as well it reduces the environmental impact and the burden on waste management practices. While devising the practices for the recovery as well as the recycling, one must understand some of the technical and scientific aspects associated with the material manufacturing. One thing one must see that net environmental impact because of these particular recovery and recycling practices must be lower than the impact which could have caused because of the use of new materials. Also, one can achieve the economy through generating the revenue by recovery and recycling of such materials. However, as we tried to discuss on the previous slide, we have to take into account the manufacturing trends, the basic technical aspects associated with that particular material. Say, for example, we can consider the example of the plastic. The common saying goes that ban the plastic, avoid the plastic, recycle the plastic. However, the way you can see here, the plastic is available in these particular 7 forms, such as PET, high density polyethylene, polyvinyl chlorides, low density polyethylenes, polypropylenes, polysterenes, and some other forms. These first 3 forms, which we normally see in the form of water bottles, certain plastic sheets, plumbing pipes, so such material is very good for the recycling. However, as we go for this particular low density polyethylene, it is used in order to prepare certain thin plastic bags which are used for some day-to-day shopping. So that plastic bags are very difficult to manage as far as environmental impact is concerned. That block the water channels, gutters, conduits, and it also causes the flooding of the storm water. So, as we think of this particular, say, LDP plastic or this particular polypropylene, or again, if we consider the example of polystyrene, which is used in order to manufacture use and throw type of glasses, plates. So that is very difficult to degrade in environment, and hence its impact is considerable. Even there could be lot many other forms of the plastic which are very difficult to recover, recycle and manage without the positive environmental impact. Hence, the way we consider the example of this particular plastic as a material, we have to think of lot many such aspects related with the various material before recovery and their recycling. Through this particular recovery, we can consider some common materials that can be recycled as well as recovered in the municipal solid waste stream. While quantifying the recyclables or recoverables, there is a necessity to have the characteristics, composition, as well as quantities of the various materials that are forming that waste stream. And after studying that, only one can have the detailed estimation of the potential for the recycling. So, as we consider the municipal solid waste stream, we can have the construction waste, plastic, steel, aluminum, yard waste, glass, paper, as well as animal waste in various forms, the way I have listed here. Further, they can be transformed into the various products through the techniques which are suggested in the layman term here. However, as far as the financial feasibility is concerned, we mostly focus on plastic, steel, aluminum, glass, and paper. The construction and demolition waste is tackled separately as far as waste management practices are concerned. Whereas this animal waste, the dung, may not be necessarily always in the form of fertilizer. Hence, we have to be very cautious while making use of such kind of animal waste for recycling or for the recovery through the waste stream. We can just have the glance about the savings from the products manufactured using these recycled materials. Here just we have considered the recycling of paper, glass, steel and aluminum. So as you see here, we can save the energy to the tune of 4% to even 97%. As well, through the recycling of the materials, considerable impact on the environment through air pollution as well as water pollution can also be avoided. As you see here, we can have the water requirement reduced to almost 50% as we follow this recycling principle. Also, as we take the example of this particular mining waste, the generation of the waste can be reduced to more than 90%. So the same concept can be made valid for other waste generation streams also. As you see here, there are a number of avenues in order to recycle the West as far as the practices observed in India. Here, at the waste generator level, the organic waste can be used as animal feed. Some of the waste can be sold to the kabadiwala. Certain segregated waste can find the access to the recycling recovery through the primary collection as well as even the secondary collection. Some of the organic contents getting generated through the kitchen in the form of food waste or certain yard waste can be used for the composting and hence can be used for agriculture or horticulture. So as you see through some such block diagrams, as far as current recycling practices in India are concerned, material that have some or other value are not lost in the waste management practices. Here, the recycling is practiced by several stakeholders at different points. However, at present, there is a lack of coordination among these various stakeholders. So, as such concept is studied in order to improve the municipal solid waste management practices in India through World Bank studies, they have devised the similar flow plan while working out the probable improvements. Hence, as there is a lack of coordination and as the findings of the study suggest there is still large scope for improvement. In order to have this particular recycling and recovery systematically done, the material recovery facility is vital element to improve the situation. So, thanks for your attention. In this particular presentation, we have attempted to understand the background of the processing. So, as we move ahead, we will discuss about the elements of material recovery facility. So, by till then, I wish you very happy learning. Thank you.